Hi, hello everybody. I am your Venkateshwar Naik from SAIMEDHA Koti, Hyderabad. We do know that the notification for Polytechnic lecturers has been out. But we also do know that the SAIMEDHA Koti is going to launch this online platform for giving training for the students of Polytechnic lecturers for civil students. Okay, so I am the trainer for surveying subject for this Polytechnic lecturers. So let us see in context of this surveying how these questions will be given for different kinds of competitive exams as well as for the Polytechnic lecturers. Okay, so we haven't seen any kind of notification of Polytechnic lecturers after the Telangana state being formed. So we have to prepare this subject in all the exams point of view so that we will be easily able to attend any kind of question from the related subject. Okay, so let us see how these questions from this area of surveying will be. Okay, so now see here I have taken a question which is a previous ESC 2019 question. Here I have chosen a few questions which are from ESC, which are from GATE, which are from AWE as well of TSPSC, to understand the strategy how this question will be given for different kinds of competitive exams. Now let us solve this very first question. In an old map, a line AB was drawn to a magnetic bearing of 5 degrees 30 minutes. The magnetic declination at a time being 1 degree east. If the present magnetic declination is 8 degrees 30 minutes east, the line should be set to the magnetic bearing of dash. Now see, this question is given from the compass surveying area of your surveying area. Okay, so how we have to deal the questions that are related to the compass surveying. Okay, so before getting into the subject, first of all I'll tell you the very basic things that we need to understand to solve a question that is given in the compass surveying. And this area of compass surveying is very important for the competitive field, because definitely you might expect a question, definitely there will be a question from this area of compass surveying. So now before getting into this question, I'll give some simple logics or the simple theory related to this compass surveying so that we will be easily able to solve whatever the kind of that question that comes in the area of compass surveying. Now let us see how it will be. Now we need to understand something called as the quadrant system in compass surveying. Okay, we have to understand what are these directions: north, south, east and west. We do know this. Okay, now we will be learning this subject in SAIMEDHA, like how this north was placed upon the top and how this south was placed upon the bottom, and what are these east and west directions as well, because here it will take much time if I go on explaining all these things related to the compass surveying. Here I will be telling the very important points that are related to the question to solve the questions that are related to this compass surveying. Okay, so now this is how the quadrant system will be there in your general compass. Okay, so see here beta, whatever the directions that I have drawn here are called true meridians. These are called true meridians. Now what is a meridian? A meridian is nothing but a reference line. In a very simple context, I will be calling this meridian as a reference line. And now this reference line is used for finding out the bearings. Okay, so simply I will be calling this meridian as a reference line. Okay, now here you can see the 4 directions which we are going to call it as true north, true south, true east and true west directions. Okay, why? Because they are geographically placed in those directions where the magnetic compass, okay, or the surveyor's compass, prismatic compass, whatever the compass that we have taken, it won't show these kinds of directions. It will be showing some other north. What is that some other north? The north that is shown by the magnetic needle. And now what does this magnetic needle will show? This magnetic needle shows the magnetic north. Why? Because this magnetic needle is placed in the magnetic field of the earth. Okay, but these directions that I have drawn are the geographical directions. Simply I will be calling it as, I can also call it as geographical north, geographical south, geographical east, geographical west. Okay, these directions are not drawn based upon a compass. Okay, but if I place a compass here at this point, now this compass will show some other north direction. Okay, now this, for example, if this is a compass, now it will show some other direction. Obviously it will show some other direction. In the very rare case, it might be coinciding this true north also, but in the general case, if you observe, this compass will show the some other north direction. Okay, now whatever the angle difference that is there, this is your magnetic north. Okay, if I extend this, you will be able to observe the magnetic south here. Okay, this is your magnetic east and this is your magnetic south. Sorry, this is your magnetic west. Okay, so these dotted lines are nothing but see here, what are these dotted lines? These dotted lines are nothing but the magnetic directions. These dotted lines are nothing but the magnetic directions. Nothing but if I place a compass here, that compass will show this direction. Okay, and now whatever the angle difference that we are observing in between these two directions or these two poles, okay, we will be calling this as magnetic declination, and this magnetic declination value will change from time to time. Nothing but magnetic variation. Okay, so that variation can be because of due to the days, or that variation can be because of due to the seasons. Okay, because actually why this variation occur will be nothing but because of the atmospheric conditions. Okay, there will be the variation in this magnetic declination. Okay, so this angle I will be calling it as magnetic declination. This angle I will be calling it as magnetic declination. Okay, now in a simple context, if you observe the definition called magnetic declination, it is the horizontal angle observed in between a geographical north and a magnetic north direction. Okay, so simple here. Now see, getting into this true meridian is nothing but a line that we are taking, or when whatever the line that we are using as a reference line, we are going to call it as true meridian. Okay, so now this is your true meridians, and here we are having magnetic meridians as well. Magnetic meridians as well. Now what are these magnetic meridians? Magnetic meridians are also nothing but the reference lines. Magnetic meridians are also nothing but the reference lines, but these reference lines are taken with respect to magnetic directions. Okay, so magnetic meridians are nothing but whatever the lines that we are taking, or whatever the reference lines that we are using with respect to this magnetic or the magnetic compass. Okay, beta, these are the geographical directions. These are the geographical directions. These are the magnetic directions or magnetic compass directions, magnetic needle directions. Okay, so now we understood what is a true meridian and what is a magnetic meridian. Now what is a bearing? Bearing is nothing but the angle. Simply, bearing is nothing but the angle. Bearing is nothing but the angle. This angle have to be taken with respect to some line, right? Angles have to be taken with respect to some line, because without having any reference line we can't find out the angle. If I say simply, if I draw simply a line here, and if I ask you to, if I ask you to find out the angle here, it is not possible to find out the angle here. Yes or no? Okay, but I need to have some reference line so that I'll be able to find out the angle of this line. Okay, now this line which I am using as a reference line, I'll be calling it as meridian, and this angle is nothing but the bearing. This angle is nothing but the bearing. Okay, nothing but bearings are the angles, meridians are the reference lines. Very simple way, very simple way. Okay, meridians are nothing but the reference lines, bearings are nothing but the angles. Okay, and here the very important point that we have to keep it in mind, like here we have seen a true meridian, magnetic meridian. In the same manner, in bearings also we will be observing true bearing and magnetic bearings. True bearings and magnetic bearings. Okay, now in a very simple context we can easily tell, like, true bearings have to be taken with respect to true meridians, magnetic bearings have to be taken with respect to magnetic meridians. Very simple. Okay, so whatever the bearing we are finding have to be taken with respect to some reference line, and that reference line is nothing but the meridian. Now if we want to find out the true bearing have to be taken with respect to a reference line called true meridian. Okay, in the same manner the magnetic bearings have to be taken with respect to only magnetic meridians. Okay, so very simple beta, true bearings have to be taken with respect to, these true bearings have to be taken with respect to true meridians, magnetic bearings have to be taken with respect to magnetic meridians, have to be taken with respect to magnetic meridians. Okay, so if you observe up to here, if you observe these points are enough for us to solve the previous question. Okay, now if you observe the previous question here, in an old map a line AB was drawn to a magnetic bearing of 5 degree 30 minutes. The magnetic declination at the time being 1 degree east. If the present magnetic declination is 8 degrees 30 minutes east, the line should be set to a magnetic bearing of. Okay, so generally if you observe any kind of materials, they will be using some kind of formulas to find out these answers. Okay, but here in our class we are not going to use any kind of formula. Here we are not going to use any kind of formula. Okay, just simply we are going to draw this figure, and from this figure itself, figure in a sense nothing but these coordinates. Okay, and from this coordinate itself we are going to find out the answer. Okay, now what are the lines that are drawn here are nothing but the true meridians. I will be calling it as true north. This is nothing but true south. This is your true east, and this is your true west. Okay, and now see, in an old map a line AB was drawn to a magnetic bearing of 5 degree 30 minutes, that is the magnetic bearing was given, the magnetic declination at the time being 1 degree east. See, now here in this question two datas were given. Here in this question two datas were given, one is regarding the old map and the second thing is regarding the present declination. Okay, now let us first solve this old one, that means let us first just represent this old one on this coordinate system. Okay, and now what did he said beta? The magnetic declination at all the time being 1 degree east. So this is your 1 degree east, this is your 1 degree which is lying towards east, you can see this is east. Okay, so now what is magnetic declination? Just we have seen the definition of magnetic declination. Magnetic declination is nothing but the horizontal angle between a true north and a magnetic north. Okay, here you can see there is a true north and this is a magnetic declination, and obviously this line will be of magnetic north. Simple, right? Okay, so this is your true north and this is the declination, and this declination angle is nothing but the horizontal angle in between true north and a magnetic north. Okay, so we have seen this 1 degree angle now. Now let us continue the question. In an old map a line AB was drawn to a magnetic bearing. See here an angle was given, a bearing was given, and he said that this bearing was a magnetic bearing, and magnetic bearings have to be taken with respect to, just now we have seen magnetic bearings have to be taken with respect to magnetic meridians only. And now here we can see the magnetic meridians. This is a true meridian, this is a magnetic meridian, right? Clear? Now the question is regarding the angle that is given. He gave this magnetic bearing of 5 degree 30 minutes. So he gave a magnetic bearing of 5 degree 30 minutes. Okay, the given bearings were given in terms of whole circle bearing system. Okay, whole circle bearing system. This is how we represent the bearings in the compass surveying. Whole circle bearing system as well as reduced bearing or quadrantal bearing system. Okay, now the given values were given in terms of whole circle bearing system. Now let us see this whole circle bearing system. In this whole circle bearing system, he gave the value as 5 degree 30 minutes. See here, this angle was given 5 degree 30 minutes. Okay, now why I have chosen this line? Because the given bearing here is magnetic bearing, and magnetic bearings have to be taken with respect to magnetic meridians, and now this is the magnetic meridian. So that's why from the north, as this given angle is in terms of whole circle bearings have to be taken with respect to only the north direction. Okay, and that too we have to move in a clockwise direction only. Okay, so all these to understand you have to attend the classes so that you will be able to comfortably learn the subject clearly. Okay, so now this was the previous year's data. Okay, so this is your line AB now and this is your line AB now. Fine. Now we have completed up to here. Now what he says, if the present magnetic declination is 8 degrees 30 minutes east, if the present magnetic declination is 8 degrees 30 minutes east, the line should be set to a magnetic bearing of dash. The line should be set to a magnetic bearing. So here the line is nothing but line AB, because this is the only line that is given. This is the only line that is given in the question. Okay, so now come to the present data. So old data was completed. Now we are going for the present data. In this present data only the declination angle was given as 8 degrees 30 minutes east. Okay, so now go for the present data. So as per the present data, the given bearing is 8 degrees. This is the present data. 8 degrees 30 minutes east. Okay, this is nothing but lying towards east, right? This line is lying towards east. This is the present data beta. Present I am representing in this color. Okay, so 8 degrees 30 minutes east is the present question. Now the question is, the line AB should be set to a magnetic bearing of dash. Now this is the line AB, right? This is the line AB. You can see here this is the line AB. And now this line should be set to a bearing of dash. Now this is the bearing that he wants. Very simple. Okay. So to find out this red angle, to find out this angle, what is it I need to do? I need to find out this angle, so that from 360, if I subtract that angle, I will be able to get that angle comfortably. Okay. Now without using calc itself, we will be easily able to solve such a kind of small calculations. Okay. Now see here, the total angle that is here is 6 degrees 30 minutes, right? So from 8 degrees 30 minutes if I subtract this 6 degrees 30 minutes, I will be able to get this angle, right? I will be able to get this angle. Fine, because this is of total, this is all total 8 degrees 30 minutes. So from this 8 degrees 30 minutes, if I remove this angle, I will be able to get this angle very easily, right? So 30 minus 30, this comes out to be 0 minutes, and 8 minus 6, this is your 2 degrees. So this angle comes out to be, 2 degrees. And 360 minus 2, because the total angle is 360 we know, okay, minus 2 degrees comes out to be 358 degrees. Okay, so here you can see the 358 degrees, the very first option, that is the correct answer. Very simple. Okay, so in a very simple manner here we will be able to solve such a kind of questions which comes in composite surveying. But if you observe the same question, if you want to observe the solutions in any kind of materials, there they will be giving something like the formulas. Okay, true bearing is equals to magnetic bearing plus or minus declination. Okay, of course we can solve with those formulas also, but no need to remember or no need to see such a kind of formulas, because diagrammatically we will be able to solve these kind of questions very easily. Getting better? So here you can see from this question itself, this angle that we need is 358 degrees. Very simple, very easy. Okay, so now let us see the next question. Yeah, the second question says the magnetic bearing of a line AB is south 28 degrees 30 minutes east. What is the true bearing of a line AB if the magnetic declination is 7 degrees 30 minutes west towards west? Now this question was given in ESC 2021. Okay, so we have to see, though the question is of a standard of ESC or any kind of gate. Okay, if you are able to solve those questions, solving small questions, it's not a big deal for us. Okay, so that's why I'm trying to show you how the standard of question will be for different kinds of exams. Now in our coaching also, that means in our training, if you get trained in SAIMEDHA, okay, so you people also will be able to learn like to whatever the standard we are going to solve. Okay, you will be able to solve all the kind of standard questions. Okay, now if you observe this question here, the magnetic bearing was given and the true bearing of the line was asked for a given magnetic declination of 7 degrees 30 minutes towards the west. Now see again, no need to use any formulas to find out the answer. Okay, so very simple. First we need to draw the coordinate system. Just we need to draw the directions, and this is your north direction, this is your south direction, this is your east, and this is your west. Okay, so all the given directions are the true directions, nothing but the geographical directions. Okay, but the given bearing is the magnetic bearing, so the given bearing is the magnetic bearing. So magnetic bearings have to be taken with respect to, remember this line, magnetic bearings have to be taken with respect to, magnetic bearings have to be taken with respect to, magnetic meridians. Similarly, true bearings have to be taken with respect to true meridians. So this is a very important point that we have to keep it in mind, so that we will be able to solve easily any kind of question. Okay, so now the given bearing is magnetic bearing beta. So the given bearing is magnetic bearing. The magnetic bearing of line AB was given as south 28 degrees 30 minutes east. Given bearing is magnetic bearing, but if you observe this coordinate system here, no magnetic meridians were there. Okay, only the true meridians were there. Okay, so now we need to have a magnetic meridian so that I will be able to draw the magnetic bearing, or I will be able to find out the magnetic bearing. Okay, but a value was given here called magnetic declination. Okay, and what is magnetic declination? Already we have discussed. Magnetic declination is nothing but the horizontal angle that is observed in between a true direction and a magnetic direction. Okay, so here the true direction already given, and here that angle shows, the magnetic declination shows 7 degrees 30 minutes towards the west. 7 degrees 30 minutes towards the west. Now this is your magnetic declination, 7 degrees 30 minutes, it is lying towards west. Okay, so no need to follow any kind of formula taking this western declinations as negative, eastern declinations as positive. No need to deal with all these kind of situations. Okay, so just simply draw the draw all the values that are given in the question. That is enough. Okay, now this is your true north, and obviously this value will be of magnetic north, and this angle is nothing but the magnetic declination. Okay, now the given value is south 28 degrees 30 minutes east. Now it is lying in between south and east. Now so for then what I will be doing here, I will extend this angle, okay, such that this is north and such that this is south. This is your magnetic south. Okay, and now see here, the given declination is 7 degrees 30 minutes. So obviously when this is 7 degrees 30 minutes, this angle will be also 7 degrees 30 minutes. Very simple, 7 degree 30 minutes. But the given bearing is magnetic bearing. Okay, so magnetic bearings have to be taken with respect to magnetic meridians. So this is a magnetic meridian, right? Okay, and east will be somewhere towards the right of this north and south. East will be towards the right of north and south, we do know. And now the given bearing is 28 degrees 30 minutes. The given bearing is something they have given it like 28 degrees 30 minutes. It is lying towards east. It is lying towards east. Okay, either whether that's a magnetic meridian or a true meridian, east will be towards the right side of the north-south line. Okay, so now this is the given angle 28 degrees 30 minutes. Now this is the magnetic bearing and we have taken this magnetic bearing with respect to magnetic meridian only. Okay, now what is the question he is asking? What is the true bearing of the line AB if the magnetic? So what is the true bearing of the line AB? So this is your line AB. This is your line AB. Now he is asking us to find out the true bearing and I clearly said the true bearing have to be taken with respect to true meridian, and here the true meridian is, this is your true meridian, and now this is the question he is asking. Very simple, easily we will be able to solve. How much he has given? 28 degrees 30 minutes plus 7 degrees 30 minutes. If you add these two, you will get the final answer. 30 comes out to be 1 degree, because this is 60 minutes. 60 minutes is nothing but 1 degree. Okay, so 1 degree will be added here. Okay, so fine, no problem. This value comes out to be 5 degrees and this value comes out to be 35 degrees. So the answer comes out to be 35 degrees 60 minutes. 60 minutes is nothing but 1 degree, and nothing but this answer comes out to be 36 degrees. And now this 30 degrees is nothing but this value, 36 degrees. And now this 36 degrees is lying in between south and east. This 36 degrees is lying in between south and east. So obviously the answer will be south 36 east. Very easy answer. Very easily we will be able to solve. Okay, beta. So very simply, without using any formulas, we are going to deal whatever the kind of question that is given in complete surveying, not compass surveying, complete surveying. We are not going to use any kind of formula here. Okay, in this complete area of surveying, we are not going to use any kind of formula. By using simple mathematics, okay, by using simple knowledge of mathematics, we are going to solve all the kind of questions that are given in complete surveying area. I am not talking about only compass surveying, I am talking about complete surveying area. Okay, now let us see the next question, how it was given. A few bearings were given here. Following bearings were observed while traversing with a compass. This is actually gate question. Line was given, 4 bearing was given, back bearing was given. Actually, it is clumsed. Okay, so this is your line, this is your 4 bearing, these are your back bearings. Okay, actually this tabular form have to be there here. Yeah. Okay, so line was given, a 4 bearing was given, A, B, B, C, C, D, D, A. This is not E beta, this is A. A traverse have to be closed. A traverse have to be closed to find out the corrections. Okay, so find here a traverse was given. Okay, A, B, B, C, C, D, D, A, and 4 bearings and back bearings were given here. Now the question is, after applying the correction, due to the local attraction, the corrected 4 bearing of the line BC will be dash. The corrected 4 bearing of the line BC will be dash. Here he is asking about this corrected 4 bearing of BC. Fine, how? Let us see. Okay, now to solve such a kind of question, generally it may take some time, because here many stations were there. Okay, because 4 stations were there here, so we have to apply the correction for each and every station. Now, how we need to apply the corrections, that is a question. Better in compass surveying, we have to understand a concept called 4 bearings and back bearings, and the difference in between these 4 bearings and back bearings comes out to be plus or minus 180 degrees. Okay, now 4 bearing means whatever the bearing we are taking in the forward direction, back bearing means whatever the bearings that we are taking in the backward direction. Okay, so in a very simple context, let us see what is this 4 bearing and back bearing here. 4 bearing and back bearing, with a simple diagram I will tell you what are these 4 bearings and back bearings. Back bearings. Okay, now see here, this is a station A, here I am having a station A. Okay, so I am finding out an angle, so this is your station B. Okay, here for example, if the angle is theta 1, and if here the angle is theta 2, if the angle is theta 2, and the difference in between these two will be obviously 180 degrees, because this angle theta 1 is nothing but this angle theta 1. Okay, so this angle is equal to this angle. If I remove this angle, obviously we will be able to get 180 degrees only now. 180 degrees only now. Okay, so let us get into this point called what are forebearings and what are back bearings. Forebearing means bearings taken in the forward direction. Now the question will be coming here, like see here, forward bearing, forebearing of AB, or he might also ask like forebearing of BA. Okay, in the same manner, the question might be like back bearing of AB, and the question also might be like back bearing of BA. Now we need to find out all these, so that it will be very easy for us to solve those kind of questions. Okay, now see here beta, forebearing, whatever the bearings that are taken in forward direction, here I will be writing, see here, bearings taken in forward direction. Here back bearings, bearings taken in reverse direction or backward direction. Backward direction. Okay, now let us see this. Okay, now forebearing of AB, that means in the forward direction we are carrying some bearing from A towards B. Okay, I am starting from A and I am moving towards B in the forward direction, and now the question is what is the bearing at A? That is the question he is asking. Very simple question. Forebearing, I am traveling with some bearing in the forward direction. I am traveling with some bearing in forward direction. So from where to where I am moving? I am moving from A towards B. So what is the bearing at A? That is the question, that's it. What is the bearing at A? The bearing at A is theta 1, simple. That bearing of A is nothing but theta 1. Okay, now if you observe here forebearing of BA, okay, here also I am moving in the forward direction, here also I am moving in the forward direction, okay, carrying some bearing, but now this time I am moving from B towards A. Now but this time I am moving from B towards A, okay. So from B towards A I am moving, carry out some bearing here. Now what is that bearing? That bearing is nothing but theta 2, very simple. That bearing is nothing but theta 2, very simple. Okay, so whatever the bearing we are calculating, from what station to what station, what is the value of bearing that we are taking to that station? That is the question, simple. Okay, now let us see this point. Back bearings, nothing but reverse direction, backward direction. That means previously we have moved from A towards B, right? Okay, now but this time we are moving from B towards A, backward direction, backward direction. And now whenever we are moving in the backward direction, what is the bearing that we are calculating from this station towards A? That is the question. Okay, now what is the angle at B? The angle at B is nothing but theta 2. Very simple. Okay, and now here also from backward direction, see, backward direction. Okay, so from A the bearing will be calculated towards B. From A it is coming in the reverse direction. Okay, so what is that angle that we are calculating here, that we are carrying here is theta 1. Okay, coming in the reverse direction, coming in the reverse direction. Okay, so now I am at B. Okay, A is coming towards B with some bearing, and now that bearing is nothing but theta 1. Okay, so in this manner, without using any formulas, we will be easily able to find out the forebearings and back bearings. Okay, now let us get into the question. Now if you observe this figure, you can clearly tell that the angle between, or the difference in the angle between forebearing and back bearing is 180 degrees, nothing but plus or minus 180 degrees. Okay, I'll tell you when we have to add, and I will be telling you when we are going to add 180 and when we are going to subtract 180 from the question, so that it will be very clear. Okay, so now see here beta, the difference in between forebearing and back bearing have to be 180, but here you can see some stations they are not having the lines A, B, B, C, C, D, D, A, some lines they are not having the difference of 180 degrees. That says that there is a local attraction. That says that there is an error in the reading that we have taken. Okay, now if you observe here beta, the difference is not 180. The difference between forebearing and back bearing is not 180. Here also the difference is not 180. The difference is not 180. If you observe here, the difference comes out to be 180. Okay, and here again it is not 180. Right? Okay, so only for the line CD the bearings were correct. Only for the line CD, because the difference comes out to be 180. Let me check once. 67 degrees 25 minutes plus 180 degrees. The value comes out to be 25 minutes. This is 7, this is 4, and this is 247 degrees 25 minutes. Yes, that is 247 degrees 25 minutes. Okay, so the given thing is correct. This line CD is correct. Okay. Oh shit. Yeah, see here. Now what is that we need to do? We need to find out the bearings. Yeah. So we need to find out the correct bearings. Okay. Now here you can see that the angle difference. Oh my God. Oh. So see here, beta. So here the angle difference is not equals to 180. This angle difference is not equals to 180. This angle difference comes out to be 180 degrees. All these were given in terms of degrees. Here the angle difference is not equals to 180. Okay. So I need to start from the CD station because the bearings that are taken from the station are correct. The bearings that are taken from the CD station are correct. Okay. So whatever the bearing that we are taking from C is correct. Whatever the bearing that we are taking from D is correct. Okay. In the same manner, you can see here the D is there here. So from D, the 4 bearing will be taken, which is also correct because here D is correct, right? Okay. So obviously the D value for the next line also, that value will be correct. And the reading is not correct here for E because the difference is not 180. Okay. Now easily we can say, so if the 4 bearing is 8 degrees 10 minutes, then what will be the value of back bearing? Obviously this value is less than 180. So when value is less than 180, when value is less than 180 degrees, then add 180 degrees. Okay, then the value comes out to be, if I add 180 here, the value comes out to be 188 degrees 10 minutes. This is the corrected back bearing. This is the corrected back bearing. But there you can see the value is 187. But there you can see the value is 187. Now what is that value here? This is not 187 here. The corrected back bearing is 188 degrees. How much beta? 10 minutes. This is the corrected back bearing. Okay. Now with what value I have corrected this, that is important. With what value I have corrected this, that is important. That means what I have done here, see, the given value is 187, but the 187 value is wrong. That do mean that I need to add 1 degree 10 minutes at E so that I will be able to get the correct answer. At E so that I will be able to get the correct answer. Very simple, right? Okay. So 187 plus 1 degree 10 minutes comes out to be 188 degrees 10 minutes. Okay. So at E, now this E can also be this is A, right? This is A. The traverse have to be closed. Okay, we need to check the question once. This is at A. Okay, so this is your question A, that is the station A. So at A, we are going to add 1 degree 10 minutes. So this 1 degree 10 minutes will be added at this A also. Okay, so corrected 4 bearing of AB. Okay, that means I need to add how much here? I need to add plus 1 degree 10 minutes. Plus 1 degree 10 minutes. Plus 1 degree 10 minutes have to be added. See here, how much I need to add? Plus 1 degree 10 minutes. Okay. So if I add 1 degree 10 minutes, then the bearing will be getting corrected. So 48 degrees 50 minutes. 48 degrees 50 minutes plus 1 degree 10 minutes, the value comes out to be this 50 plus 10, which comes out to be 60, 60 plus 162, see here, 48, 49, this value comes out to be 50. Okay, so this value comes out to be 50 degrees, 48 degrees plus 149 degrees plus both 50 minutes plus 10 minutes comes out to be 60. 60 means nothing but 1 degree will be added. So here you have to get 50 degrees. That means the corrected bearing here is 50 degrees. The corrected bearing is here 50 degrees. Okay, so now when AB is corrected, okay, that means the corrected forebearing of AB is 50, then obviously what will be the back bearing of AB? What will be the back bearing of AB, as this value is less than, this is your AB, this value is less than 180, so just I need to add 180, so 18 plus 5, which comes out to be 230 degrees. 230 it have to be here. Actually the correct bearing is here 230, but here how much it is there? 232. That means I need to subtract minus 2 degrees, so that I will be able to get the correct value. This actually the value have to be 230 degrees, but here I have got here in the question I have got 232. That means if I subtract minus 2 here, I will be getting the correct answer. Now this is at minus 2 for it, where? For B, and again here also you will be able to observe the B. Okay, so minus 2, here also I need to subtract minus 2, so that I will be able to get the correct answer. So if I subtract minus 2 here, this value comes out to be 128 degrees. This value comes out to be 128 degrees 50 minutes. 128 degrees 50 minutes have to be there. Now that is a question he is asking. That is a question he is asking. The corrected forebearing of line BC is how much? 128 degrees 50 minutes. Okay, now to have a cross check, what is it we are going to do here? 128 degrees 50 minutes, as this value is less than 180, we need to add 180, so that the final resultant will be 50 minutes. This comes out to be 8, this comes out to be 0, this comes out to 308 degrees 50 minutes, and now that is there here. Because that is correct, C is correct already, the C is correct because it is not having any error, So we can also cross check the question in this manner. Whatever the solution that you got, we can cross check it out. Okay, so without doing much calculation, we will be able to solve this kind of question also, but if I solve in that manner, you people won't be able to understand. Okay, we people won't be able to understand, so that's why I have elongated it to some extent. Okay, so now this is how we are going to solve this kind of question. Okay, now let us see the next question, which came in GATE 2015. In a region with magnetic declination of 2 degrees east, the magnetic forebearing of a line AB was measured as north 79 degrees 50 minutes east. There was a local attraction at A. To determine the correct magnetic bearing of the line, a point O was selected at which there was no local attraction. The magnetic forebearing of a line AO and OA were observed to be south 52 degrees 40 minutes east and north 50 degrees 20 minutes west respectively. What is the true forebearing of line AB? Good question. So the next question was given here. Now he said that there was a line AB, okay, and from this line AB the forebearings were taken here for this line AB, but he says that there was a local attraction at A. So whatever the bearings that we are taking from A are wrong, okay, because there is some local attraction, and because of this local attractions there will be an error. This local attraction leads to the error. Local attraction causes error, remember this, okay, and now I have to remove that error. Okay, so okay, to determine the correct magnetic bearing of the line, okay, up to here the question we have seen. To determine the correct magnetic bearing of the line, a point O was selected at which there was no local attraction. Okay, so a point O was selected where there is no local attraction, fine. And the magnetic forebearing of the line AO and OA were observed to be south 52 degrees 40 minutes east and north 50 degrees 20 minutes west. So here two bearings were taken, that is forebearing of the line AO and forebearing of the line AO and OA were observed to be here. Now see here, he said that there is some error here, and there is no error at O, because he himself said that a point O was selected where there is no local attraction. Okay, that means A is having local attraction where he said clearly. Okay, now we need to find out the local attraction. We do know the forebearing and back bearing difference. Forebearing of AO and minus forebearing of OA comes out to be 180 degrees. Okay, forebearing minus back bearing, or if you want to solve, you can solve in this manner. Forebearing of AO minus back bearing of OA is nothing but AO is equals to 180 degrees. Okay, you can also find out in this manner also as well. Okay, so nothing but here the bearing that we are taking here, this is nothing but this bearing given, this is nothing but this bearing is given, according to the previous concept that I have said to you clearly. Okay, now see here, the bearings were given in terms of reduced bearings. We have to convert this in terms of a whole circle bearing system to solve this question easily. Okay, now that is very important. The given bearing here, is south 52 degrees 40 minutes east. One bearing is given here like this, and one more bearing is given north 50 degrees 20 minutes west. Okay. Now, how we are going to find out this in terms of whole circle bearing system? So, the given bearing is lying in between south and east. This is your south and this is east. The given bearing is this one, which comes out to be 52 degrees 40 minutes. Okay. If you observe here, the given bearing is given in terms given in between north and west. So, this is your north and this is your west. So, given bearing is reduced bearing system. So, 50 degrees 20 minutes west. To understand this concept, you need to attend the classes. You need to take the classes, no other option. Okay. So, the given bearings were here like this. Now, we need to find out what whole circle bearing, and whole circle bearings have to be taken with respect to only north. Okay. Whole circle bearings have to be taken with respect to only north. Now, these are the bearings that we need to find it out. Okay. So, see here, if I subtract 52 degrees 40 minutes from 180, I will be able to get the remaining angle. That means this 180 degrees is there, right? So, if I subtract this angle 52 degrees 40 minutes, I will be able to get the resultant value of this bearing, this value, because we know this is total this is 180. Okay. So, without using calci, how I am going to solve this? This 180 I am going to call it as 179 degrees 60 minutes minus 52 degrees 40 minutes. Okay. This comes out to be 20 minutes here, and 9 minus 2 this comes out to be 7, 7 minus 5 this comes out to be 2, the value comes out to be 127 degrees 20 minutes. Okay. So, this value comes out to be 127 degrees 20 minutes. Okay. Now, here if you observe here, we need to subtract this value from 360, so that you will be able to get the correct answer, and this 360 I will be writing it like 359 degrees 60 minutes minus 50 degrees 20 minutes. The value comes out to be, this value comes out to be 40 minutes, and 9, 5 minus 5 0, and this value comes out to be 3. Okay. So, the value is here 309, the given angle is 309 degrees 40 minutes. So, we got the fore bearing and back bearing. Fore bearing of AO was observed here, back bearing of AO is also observed from this figure. Now, the difference have to be 180 here. The difference have to be 180 here. Okay. Now, let us see. Now, if you observe here beta, if you observe here, back bearing is taken from O station, right? Back bearing is have to be taken from O station. So, this value will be correct. Okay. So, that means here whatever the figure that we are taking here, this figure will be correct figure. Okay. But here this is fore bearing, the fore bearing value A is wrong, because he himself said that there was a local attraction at A. Okay. Now, let us see how we are going to correct this. Now, let us see how we are going to correct this. Okay. Now, the given value is 309 degrees 40 minutes. Already the previously we have said the back bearing is given as 309 degrees 40 minutes. If I subtract 180, because this is greater than 180, okay, I will be able to get 40 minutes. This is 9. This is this value comes out to be 10 minus 8. This value comes out to be 2. This comes out to be 129 degrees 40 minutes have to be there. Okay. But here if you observe, the value comes out to be only 127 degrees 20 minutes. Because of this here we are having an error. Okay. Now, we need to rectify this error. Now, to rectify this error, what is that I need to do here? See, if I subtract this 127 degrees 20 minutes from this value, you will be able to get 2 degrees 20 minutes as an error. Okay. That means if I add this 2 degrees 20 minutes here, if I add this 2 degrees 20 minutes here, this value comes out to be 129 degrees 40 minutes, which is correct answer, which is the correct answer. Okay. That means what I am doing here, just I am rectifying this error by adding 2 degrees 20 minutes, by adding 2 degrees 20 minutes. Okay. Now, okay, this is an correction that have to be applied. This is a correction that have to be applied. Okay. So, now we found out the error. Now, we found out the error. Okay. Finally, we got this error. Yeah. So, see, let us how we are going to solve this. I will erase some area so that I will be able to have some space. Okay. So, now what is that correction that I need to apply here? The correction that have to be applied here is 2 degree 20 minutes. Now, see here. Now, for the question, now in a region with magnetic declination of 2 degrees east, the declination is towards east, this is 2 degrees that is given here. Okay, the magnetic fore bearing of the line AB. So, the given bearing is magnetic bearing. So, this is your true bearing, this is your magnetic bearing, magnetic meridian, sorry. Okay, so the given bearing is magnetic bearing. So, magnetic bearing have to be taken with respect to only magnetic meridian. So, that's why I have written the magnetic meridian here. Okay. So now the question is 79 degrees 50 minutes. The given bearing is given for bearing of AB, given for bearing of AB is 79 degrees 50 minutes, which is lying in between north and east. So I need to apply correction for this. So after applying this correction, that is 2 degrees 20 minutes, the value comes out to be north 79, 80, 81, 82 degrees 10 minutes east. If you simply add 79, 50 plus 2 degree 40 minutes, the value comes out to be, this is 10 degrees, this is 1, 9, 10, 11, 12, yeah, this is 82 degrees 10 minutes. So the correct value will be 82 degrees 10 minutes. Now that is what we need to consider. This is the wrong value. The correct value is north 82 degrees 10 minutes east is the correct value. Okay. So it is lying in between north and east. So this is the value that is there given, 82 degrees 10 minutes. This is the bearing that is given. Okay. Now the bearing is regarding, the question is regarding what is the true forebearing of the line AB. So this is nothing but the true forebearing of the line AB. Okay, nothing but 82 degrees 10 minutes plus 2 degrees comes out to be 84 degrees 10 minutes, which is the correct answer. 84 degrees 10 minutes, where is it? Yeah, it is nothing but option 3, north 84 degrees 10 minutes east. Now this is the value, that means this is how we are going to solve this question. Very simple question, but he gave a combination of 2-3 concepts. That is nothing but he introduced this the difference in between forebearing and backbearing concept, which have to be 180 degrees. Okay, so very simply we will be able to solve all these kind of questions. Okay, now let us see the next question. At magnetic poles, yes, this question was given in TS Transco 2015. At magnetic poles, the magnetic dip of a magnetic needle is dash. Now to understand this better, we need to understand what is a dip angle. To understand this, we need to know what is a dip angle. Dip angle. See here, we need to understand what is a dip angle. Okay, dip angle is nothing but when the compass is vertically mounted. When the compass is vertically mounted. When the compass is vertically mounted, the angle made by the compass or by the magnetic needle in the vertical plane with respect to a horizontal line, in vertical plane with respect to a horizontal line, with respect to a horizontal line. So this is nothing but dip angle. Now to understand this, I will tell you with a simple diagrammatical manner. Now this is our Earth's surface. Okay. So upon this Earth's surface, we will be having the magnetic field. We do know this. The Earth will be having the magnetic field. And now whenever we are bringing a magnetic needle into this magnetic field, this magnetic needle will tend to move towards the north, because south attracts the north. Okay. Because unlike poles, they will attract each other. Okay. See, this is the magnetic needle that is present inside the Earth's surface. This is your south pole. This is your north pole. And see here, the magnetic field lines, they will be flowing in this direction. They will be flowing in this direction. Okay, so these are the north field lines. Okay, so if you observe here beta, the north field line flow is observed in this direction. So that's why we write north upon this manner here. The north direction will be shown here like this. Okay, so now if you observe here, that's why we will be writing north here like this. Nothing but this line represents, this arrow represents the magnetic field line flow. Okay, now when I am bringing this compass, which is vertically mounted, it is not in the horizontal plane now. Generally we do observe the angles in the horizontal plane. Now what is that we are doing here? I am changing the compass into a vertical plane. Okay, now with this vertical plane also, this magnetic needle, it will tend to show some north direction. Okay, it will tend to show some north direction. Okay, and now that angle that is shown here, for example, if this is the Earth's surface, for example, or else I will take this shape of the Earth. This is the Earth's surface. This is the Earth's surface. Okay. Now, whenever we are bringing a vertically mounted needle whenever we are bringing a vertically mounted needle, for example, this is a needle, a vertically mounted needle, okay, which shows the north direction. Okay, now this vertically mounted needle, it is showing some north direction with respect to an imaginary horizontal line. Whatever the angle made here, this angle is nothing but angle of dip. This angle is nothing but angle of dip. Okay, beta. So when this needle is vertically mounted, whatever the horizontal angle that is made by this needle, we are going to call it as angle of dip. In the same manner, we have seen this angle of declination also, that is angle declination angle. Okay, declination angle is an horizontal angle, dip is an vertical angle. Okay, now the point is here, the question is regarding, if you observe the question, at magnetic poles, so generally we will be observing north pole here. These are the geographical poles. Okay, so at poles, what is happening here, whenever we are bringing this needle at poles, now whenever I bring this needle towards here, obviously it will tend to move towards down direction. Okay, so if I take this horizontal angle or horizontal line as a reference, this line makes an angle of 90 degrees with respect to this horizontal. Okay, very simple, because this is north pole, that is north pole. The magnetic needle, it will show towards south, because unlike poles, they attract each other. Okay, so very simply at poles, what is happening here, it will try to show you this north, this magnetic needle, it will be showing you the 90 degrees angle with respect to a horizontal line. Okay, so that is very simple question. So obviously at magnetic poles, the dip of the magnetic needle is 90 degrees. It will be 90 degrees. At the equator, it will be 0. 0 at equator, at equatorial axis or equator. Because at the equator, it will be having the influence of both north and south. Okay, so that's why it won't have any it won't have any dip angle. It won't make any move, because it will be having the influence of both the poles. So that's why it won't make any move. Okay. So now let us see the next question. The magnetic declination of a place, if the magnetic bearing of the sun at noon is 352 degrees 40 minutes. To solve this question, I will tell a very simple shortcut so that you will be able to solve very easily. Draw the directions north, south, east and west. Okay. So the declination is given as 352 degrees 40 minutes. The angle is given as 352 degrees 40 minutes. Okay. So whenever a question comes like the magnetic bearing of the sun, magnetic bearing of the sun, start from south, move in anti-clockwise direction and draw the angle that is given. Okay, so 352 degrees 40 minutes, it will end somewhere here. It will end somewhere at this point. Now this angle is nothing but 352 degrees 40 minutes. Okay, nothing but here. Simply follow a shortcut. Start from south. Number 2, move in anti-clockwise direction. Draw down the angle. Okay, so if you see here, this angle comes out to be 352 degrees 40 minutes. Now the remaining angle, what is this remaining angle? This remaining angle comes out to be 360 minus 352 degrees 40 minutes. Okay, nothing but I will be writing it like 359 degrees 60 minutes minus 352 degrees 40 minutes. The value comes out to be 20 minutes here. This value comes out to be 7 degrees. This is 0. This is 0. Nothing but 7 degrees 20 minutes. Okay. So this value comes out to be 7 degrees 20 minutes. If I extend this here further, obviously this angle also will be 7 degrees 20 minutes. And now this is lying in towards east. So the declination is 7 degree 20 minutes east. The declination angle is 7 degree 20 minutes east. Okay, because the declination will be either towards east or west. It won't be towards north or south, because see, east or west, the declination will be towards either east or west. Only two declinations we will be having. They are eastern declination and western declination. Eastern declination will be always positive. Western declination will be always negative. Okay, very simple shortcut. No need to use any kind of formulas. Very easily we will be able to solve the questions. Okay. Not only these questions, but whatever the kind of question that comes from whatever the kind of competitive exam. Okay. So here we are not worrying about our no need to have no need to have any tension for any kind of question that we observe in compound surveying, because we will be able to solve whatever the kind of questions with whatever the kind of model. Okay, so very easily, without using any formula itself, we will be easily able to solve the questions easily, comfortably in the complete area of surveying, not only in compound surveying. Okay, so here we people of SAIMEDHA, I think you do know, the JL, the PL batch has started. Not for this offline course here, we are having only online course. Okay, present currently this SAIMEDHA people, they were giving, they are offering this course of Polytechnic lecturers. Okay, only in online mode, not in the offline mode, and they are charging, that means the fees that we do know that the other organizations, if you observe the fees of these kind of coachings, they'll charge around 30,000, 40,000 like that. Okay, but here as an offer, these people were giving this course of Polytechnic lecturers, complete course of Polytechnic lecturers, which includes technical and non-technical. Course includes technical and non-technical. Remember this. Course includes technical and non-technical things, technical videos and non-technical videos, completely recorded videos, technical videos as well as non-technical videos, non-technical as well. All the subjects which is given the complete syllabus were provided in terms of recorded videos, Okay, so the complete course actually the fees they were charging around is 12,999. The fees they are charging around is 12,999. But for the very first 100 people, they were charging for a cost of 6,999. They were charging for a cost of 6,999 only. That too only for the first 100 people, for the first 100 students only. And thereafter, I don't know how the fee structure will be. Obviously, it will be more than this cost. Okay, so obviously it will be more than this cost, but for only for the first 100 students, you will be able to avail this complete offer at a charge of 7,000 rupees. Okay, to be more precise, 6,999. Okay, so here we are, you might be having some questions like, sir, what about if the doubt comes, or what about if you want to interact with the faculty? But after taking this kind of course in this online, you will be able to have this comment section or the chat box where you can express your doubts, or else we will be giving our numbers as well on the screen. That means the faculty members, they will be giving their numbers on the screen, so that you will be able to call the faculty, or you will be able to interact with the faculty directly, because we people will be there with this SAIMEDHA only throughout the day. Okay, so if you are having any questions, kind of doubts in all the subjects, whatever the kind of subject that is, okay, so you may express your doubt either to any kind of text message in that app, or else you can also contact with the faculty directly, so that you will be able to have the direct interaction for the problem solutions. Okay, so this is a charge that is currently the SAIMEDHA. To avail this, to get this Polytechnic lecturers course, you need to pay a charge of around, you need to pay a fees of around 7,000 rupees. Okay, so for this course, for this charge, you will be able to have all the technical subjects, non-technical subjects with recorded versions. Only the recorded videos will be there. You can watch any number of times at any place. Any number of times at any place. They are only the recorded videos. Okay, so you can listen if you are having it is not like only the live session beta, it is a completely recorded session, so that you will be able to observe any number of times that you want. You can learn any number of times. If you want to see any number of times, you can see it. There is nothing like there are no limits for this number of views. Okay, so you can have you can watch it any number of times. Okay, so if you are having any questions also, you will be able to have the interaction with the faculty as well. Okay, so after buying this course, you will only be able to see how the course is planned in this app. One important point that I want to add here is, here in this Polytechnic lecturer course, we are not only going to deal this TSPSC questions, we are going to deal with the GATE questions, we are going to deal with the ESC questions, we are going to deal with any other PSC questions also as well. Okay, because if we people were able to solve all the questions, or that means all the competitive exam questions, it is very easy for us to solve the Polytechnic lecturers questions. Okay, that means we are going for a maximum standard where we will be able to reach whatever the kind of question or whatever the kind of concept that is. Okay, as we are having enough time to attend this exam called Polytechnic lecturers. Okay, so hurry up, get this admission for this SAIMEDHA. Okay, prepare well. We will be easily able to get the job comfortably without having any trouble. Okay, thank you.